Assalamualaikum and hi to everyone. My name is Siti Saida Ishaq. I am a PhD student for course Civil Engineering. This is my research title, Seismic Resistant Precast Concrete Structure, a study on precast building connection to resist seismic load. Thus, during my PhD journey, I will investigate further about this topic. And my main supervisor is TS Dr. Rozaina binti Ismail and my co-supervisor is TS Dr. Haja Nuliati binti Muhammad Amin. These two important persons who will assist me during the study. As an executive summary, precast concrete facilitate a construction method using durable and rapidly erectable prefabricated members to create cost-effective and high-quality structures. In this method, the connection between the precast members as well as between the members and the foundation requires special attention to ensure good seismic performance. In this study, the investigation of the seismic response on the precast due to connection which related to three different systems that are moment frames, structural wall, and floor diagrams. As introduction, IBS system or precast concrete building is gaining its popularity globally and in many developed countries. Precast buildings are preferred over cast in situ place construction due to the many advantages. Nowadays, we can see many bridge and highway constructions adopted the IBS system in their construction method beside residential and high-rise building. Precast concrete products are high in quality and uniform standard as they are mass-produced under a controlled environment in a manufacturing plant. Even though the precast components are difficulty in transporting due to heavy and large size, the speed of installation is more reliable compared to the cast in situ concrete. All components are designed for simple connection to allow many components to be installed in a short time. The seismic behavior of precast building structure is highly dependent on the characteristics such as strength, stiffness, and deformation capacity of the connection between the precast structure members and between the members at the base and the foundation. Poor performance of precast building in past earthquake has often been attributed to poorly designed or poorly built connections. All precast components are designed for simple connection to allow many components to be installed in a short time. The design of joint for the beam column connection is very vital for seismic resistance of modern structural buildings such as reinforced concrete, steel, and precast concrete buildings. The importance of beam column connection is recognized for the structure integrity. As such, beam column connection is necessary to be capable to resist and sustain load transmitted from beam and column with sufficient stiffness and strain. Therefore, in this research, the connection of beam column will be investigated and studied further how the connection can influence the structure to be sustainable and can resist any seismic load impacts. For problem statement, seismic load is generated by ground shaking or vibration of the earth, whether due to natural or artificial causes. The survivability of a structural building through an earthquake mainly depends on the earthquake response controlling parameters such as stiffness, strength, and ductility. The higher the magnitude of the earthquake can cause the structural building swaying in large deformation or displacement. In the research of structural stability of precast concrete structures, the beam column connection is the main element governing the structural behavior in responding to various loads such as seismic load. Different type of beam column connection has different bending moment stiffness. The bending moment stiffness can control the amount of induced bending moment being transferred among structural members of a precast concrete skeletal frame. Consequently, it will affect the deflection behavior of structural members. Large deformation of structural building in response to earthquake can be reduced by increasing the stiffness of its frames. At the same it reduces ductility of frames. However, capacity of structural members is easily achieved to limit as less energy released from earthquake losing through small displacement. High ductility may allow the structural building swaying too much in displacement. However, the capacity of structural member is not easily achieved as most of energy from earthquake losing through large displacement. For scope of study for this research, the connection between precast elements can be achieved through bolting, grouting, and welding. There are different types of structural connection used for various components of precast structures, such as column to foundation connection, wall panel to foundation connection, beam to column connection, column to column connection, floor to beam connection, and wall to wall panel connection. However, in this study, the focus is on precast beam column connection. The investigation of the seismic response on the precast structure due to the beam to column connection behavior. Seismic load could damage the whole structure if it is not properly designed, especially in high seismic region. Beam to column connection provide more resistant connection between beam and column at the corners of frame, or a moment resisting rotational stiffness connection to elongate beam. The connection configuration and response, including strain, rotational stiffness, and ductility, affect buildings in several ways. For this dry and wet connection are possible in the beam to column connection. There are three types of connection for precast beam to column. That is rigid connection, semi-rigid connection, and pin connection. Objective of the study for this research. The objective of the study is to be taken. The study will specifically focus on construction in Malaysia and in general the surrounding neighborhoods that are in the earthquake ring. Example, Philippines, Indonesia, and China. The objective is also to study on the role of precast connection in seismic region and their relationship to selected behavior factors Q as used in the Eurocode, ductility factors, micro or reduction factors R. Besides that, the objective is to study knowledge on how the concept of seismic can be adopted in precast connection and safe to apply in the construction, and also review few connection products that usually being used in the industry nowadays and the guidance in future project implementation to minimize the damage on the building and able to withstand seismic loading. For literature review, as introduction, the purpose of connection in the precast building is to transmit force between structural components, provide overall stability, and prevent external leakage in the complete precast structure or building. The structural connection between the components will form an essential part of the structural system. Seismic load analysis is a procedure used to determine the force a building or a structure will experience during an earthquake and evaluate the building's ability to withstand those forms. While seismic resistant is a building or structure that is able to withstand the sudden ground shaking that is characteristic of earthquake, thereby minimizing structural damage and human death and injury. Connection in seismic precast structure system are typically completed in the field during erection. A construction space is often created at the joint for tolerance and alignment purposes. Precast concrete system composed of element joint using strong connection are recommended to be designed using capacity design concept. Example of strong connection for beam to column, and column to footing. These connections are intended to experience flexural yielding outside the connection. Precast concrete beam column connection. Depending on their stiffness, Precast concrete beam to column connection are classified as a pin or rigid connection. Connection with low stiffness are classified as pin connection, while those with high stiffness are fixed connection. Beam column connection can be divided into three types: flexible connection, that is hinge or pin, rigid joint, and semi-rigid according to different rotational stiffness. Type of beam column connection. In this research, three types of beam connection we will investigate. That is rigid connection, when the moment capacity of the connection is the same as the moment capacity members. Semi-rigid connection. Semi-rigid connection are considered in prefabricated structure. And last one is pin connection, when two structural members are connected by means of cylindrical shaping. In this study also, we will elaborate detail regarding method of seismic analysis. Seismic method of analysis is done in order to ascertain the various responses of building during earthquake and also to adopt the retrofitting of structure. This method analysis is also important for design of element of RCC building like beam, column and slab. Three basic methods are available for analyzing the response of a structure subject to seismic ground wave are static analysis, response spectrum analysis and time history analysis. For research methodology, in this study, we have three stages of methodology. Design stage, experimental works or analysis of design, and result stage. Two methodology can be adapted in the research to investigate the process that are structural modeling and finite element and experimental of specimen. Three steps will be taken to accomplish this study, which are design stage, experimental work, analysis of design stage, and result analysis stage. These steps have illustrated in the above flow chart. This is a Gantt chart. The Gantt chart shows the expected timeline for the research works based on timeline given by university for PhD course duration. I just adapt into my timeline. Okay, status major research milestone. For writing report, executive summary completed, problem statement completed, scope of study completed, objective of study also completed, while literature review still in progress. The content will be elaborate more in full research. Research methodology also in progress. Result in discussion not yet done. Required data from analysis or experimental work. Conclusion and research also not yet done. This part will be prepared after completed the research. Planning for the next year, develop the details for literature review and research methodology, and also implement the experimental works to elaborate the result into the next chapter of research report. And to complete the JRP, also for publication, target to do 1 or 2 publication for research work. Okay, that's all for now. Thank you. Bye-bye.